Welcome back to our channel. It's okay. Remember, if you like our sharing, support us. Like, follow, and subscribe. Also share with your friends. Okay. So question 3a is about outlights. Okay. What is meant by traveling wave? So what is meant by wave, and then what is mean by traveling wave? Okay. First, okay, you have to say wave is a periodic oscillation. It's a very fundamental, right? If it is not a periodic oscillation, then how can it be a wave? But if it is a periodic oscillation, it still has to be some special feature if it is a wave. Remember, wave, traveling wave is a transfer out of energy, right? So energy is transferred out, but just energy, remember, not the particle, not the medium, right? It is transferred out of energy. But you have to say clearly without, okay? Without is important. The medium is still there, the medium doesn't move, okay? Without net movement, you can say, or net motion of what? Okay, you can't say particle, right? Because sometimes it's electromagnetic wave, right? So net motion of medium. Okay, you can say the medium does not move, okay? That's it, okay? And then go down, it's about stationary wave. So it's a pipe open and close, okay? Okay, B1, okay, outline how the standing wave is formed in the pipe. Remember, incident wave, refracted, and then these two wave interview, right? So this is the 2 points you would need to say. So for A, you need to say the wave is refracted. Where? At the, how to describe this space? Close end, okay? It is refracted at the close end. And then how do the standing wave formed? By the interference, remember, between the incident and refracted wave. And then you have to say interference of the incident. Incident is incoming, right? And the refracted wave, okay, so two wave interfere, and they form the wave, okay? Good job. Determine the wavelength of the wave. So get some data. Wavelength. You got it. 1.2 meter is this length. But how many waves are there? So first of all, remember this is a 1.2 meter. Sometimes label it on the diagram helps you. And you have to count the wave. Look at the solid line. Okay. Half a wave and then another quarter. So it has a 3/4 of wave. So 3/4 of wavelength equals 1.20. And then so you got lambda is just 1.60 meter. So it is part 2. Last part, calculate the speed of sound. V equals F lambda, right? So frequency equals let me find the bridge. Okay, maybe here. Okay, frequency equal speed over lambda. Speed is sorry, we need to find the speed. V equals F lambda. So frequency is got it here. 210 hertz. Okay, so 210 multiplied by the wavelength we got 1.60 meter. Because all are v significant, okay? So the result, the speed is also v significant, okay? Try to get it, okay? What is it? Yes, 336 meter per second. Well, then this is the result of part 3. We make it. Well done.